This is IGCSE Computer Science Syllabus Statement 1.3.1b. Use logic gates to create electronic circuits. So, as you can see, this looks a bit different. So what I'm using is a logic simulator called Logisim to create electronic circuits with logic gates. So what you're going to need to do first is, if you haven't already, watch 1.3.1a to understand all of these logic gates here, because you're going to need to know the logic gates and their truth tables in order to actually understand what's going on here. So once you've done that, we can get started. So here we have input, so we can have two inputs, and here we have output, so we can have an output here. So just to refresh your memory, I'm just going to click this and put this here, drag the wire here. This is pretty much how a logic gate, well, the NOT gate in this case, will work. So it's basically, as you can see, inverses the bit. So we give it 1, output 0, give it 0, and output's 1. I won't go through all of the gates now because that's all covered in that video, 1.3.1a. So go ahead and watch that to actually understand, but I'm just going to show you an example of how this works. So you just click this for to change between 0 and 1. So let's try creating a circuit. So, well, we learned about logic gates in the last video in order to create circuits. And in the exam, you're going to need to create circuits as well as look at them and then produce truth tables for the circuits, which we'll go through in the next video. So, last time I recorded this video in my older series, this video was about an hour long, but this video, this one right here, should be 10, maximum 15 minutes. Hopefully not that much, but we'll see. Should probably stop talking and get on with this. So we're going to be using the NOT, AND, OR, NAND, NOR, XOR, and XNOR gates. So let's create a basic logic circuit. We can use the AND gate, the NOT gate, and let's do the NOR gate, and yeah, let's pick the XOR gate. Now this circuit is quite special because well, actually you're going to see why just in a second, but once I've connected these wires, that is. But basically you're gonna find out why this is special, and you're gonna see that. Well, yeah, that's it. I don't want to spoil anything too much, but you'll see what I mean. So I've dragged these wires here and to the output. So 0. Well, actually, first of all let's label these to make it clear. This is A, this is B, this can be X. So let's try changing the inputs. So 0, 0 makes 1. 0, 1 makes 0. 1, 0 makes 0. And 1, 1 makes 0. So what do you notice about this? Well, in case you haven't noticed, take a look at the output when we give it different inputs. 0, 0 makes 1. 0, 1 makes 0. 1, 0 makes 0. And 1, 1 makes 0. If you haven't noticed, this is actually the truth table for, well, it has the same, well, this circuit has the same truth table as another logic gate. So let's find out which one. So we'll do the same thing here. I think I can copy this. Yep. Let's move this over here. I'm just going to move the B up a bit. So this is why I told you to look at the other video so you can actually understand the truth tables for the other logic gates. So you'll notice 0, 0 makes 1, 0, 0 makes 1. 0, 1, 0, 1 makes 0. 1, 0, 1, 0, both make 0. And 1, 1, 1, 1 makes 0. So this entire logic circuit can be simplified to this little logic gate here. So that's one of the things that you may be tested on in the exam. So they might ask you to give the logic gate, which can, give the logic gate which the circuit can be simplified to. So like, it's the reason actually is because if you're buying physical logic gates, like if you're building a computer, then it's good to keep it simple so you can save money. That, and I'm just gonna move the. Actually, it doesn't really matter. It's kind of weird. All right, so let's get rid of that and try something else to wrap this video up, because, this video is kind of, I think it's gonna be long if we don't. So this logic circuit will have 3 inputs. So we can name these A, B, and C. So we're going to try to create a circuit using all of the logic gates that we've learned so far, all 7 of them. So we start with the AND, put that there. The NOT, definitely, let's put that there. The OR, I might have to spread it out a bit actually, because the circuit might be a bit big. Let's move that down. Oh, missed that. There, okay. So, A, B. Will this work? Yeah, I think that'll work. And we can have C there, of course. So let's try adding the OR gate. Put that there. And we can drag A here. This might look a bit weird. We can have the XOR gate here. I know this seems really boring. Sorry for that, but what you can try to do is get used to doing this on paper, actually, because that's what you're going to have to write the exam in. That's what you're going to have to draw logic circuits in as well. So we have the NOR gate here, and we just need to add the NAND gate. And finally, we can add our, we have 6 now. We can add our final XNOR gate right here. So we drag this input down here, or this wire rather. And then we can have an output here. So if you try to, if you're using the simulator, and you try to click the, I'm just going to put that there. If you try to click the inputs, you get something like this. You can try out these different combinations, see what outputs you can get. Now I won't go much on the truth tables this video, because as said, we're going to look at that in another video, which is actually the next video. So what we're actually going to do is we're going to take both of the logic circuits that we learned in this video and then produce truth tables for those circuits. So if you've done this on paper, you might want to save it. If you've done it in the logic simulator, you might want to save it for the next video.